plugging in, we're getting into chapter 3. If you notice, chapter 3 is entitled Solving Systems of Equations. And so our focus of our chapter is going to be looking at various systems of equations, and we're going to use different techniques to solve them. So the first way we're going to talk about is graphing, and that's what we're going to talk about today. And so we're going to define what a break-even point is. And so when you're talking about businesses, a break-even point is a point at which income equals cost. And so a lot of businesses are really interested in this point because they've got to get to the break-even point so then they can start making some money. Because up until that break-even point, they're actually losing money. Okay? So anyway, I think you'll end up using that in your homework. And so if you look at this first one, and you all have your sheets there to look at, it says solve the systems of equations by using a table. Okay? So what we're going to do is we're going to pick values of x. And we're going to try to find the x and the y that fit both of those equations. So we could go ahead and start with, I don't know, what do you want to try? X is 1? Do you want to try 1? So what we're going to do is we're going to plug 1 in for x in the top equation. And when I do that, I get 3 plus 2y equals negative 2, right? Okay. So I get 2y, if I subtract 3, I get 2y to equal what? Negative 5. So what does y equal? Negative 2.5, right? Negative 5 halves. So now what I'm going to do is I'm going to plug that in and see if that fits in the bottom equation. So if I plug in 1 for x, I get negative 4. If I plug in 5, negative 2.5 for y, I get, what is that, negative 12.5? Does that equal negative 28? Nope, doesn't. Okay, so we're close. It's actually negative 16.5. So we need to get a little bit bigger. So instead of x being 1, what do we want to try x as? 3? You want to try 3? So if x is 3, let's plug it into the top equation. Plug 3 in up here. What do I get? 9 plus 2y equals negative 2. Subtract 9, so you get 2y to equal what? Negative 11. So what does y equal? Negative 5.5. So let's see if we're getting closer. So if I plug in 3 for x in the bottom equation, I get negative 12 plus negative 27.5. Whoa. Does that equal negative 28? Nope. So what should we try now? 2. Okay, so let's plug in 2. So if I plug in 2 to the top equation, I get
6.
Yep, so plus 2y equals negative 2. So what does 2y equal? Negative 8. So what does y equal? Negative 4. So let's plug that in. If I plug 2 in for x, I get negative 8 plus negative 20. Does that equal negative 28?
Yes.
Winner, winner, chicken dinner. So your solution then is going to be 2, negative 4, and so that's what you would need to write. Now this is just a trial and error. This is kind of, you know, one of those things that you're just going to use your best judgment. Kind of see where you need to go.
Is there going to be decimals on this where we have to, like, it would be 2.5 for x?
No, I don't think so. All right, so do you want to look at another one, or do you think you can handle it? You think you can handle that? Okay. All right, so next one says solve the following systems of equations by graphing. So now we're going to graph these by hand. And so this is where that gold sheet that I gave you last chapter could come in really handy, because what form are each of these equations in? Standard form. So if you remember standard form, I can look at that and give you my slope. My slope in this case is going to be negative a over b. So negative, what's a?
2.
2, what's b? Negative 1. So my slope is 2. My y-intercept is defined as being what over what? C over b. So C is what? -1. B is -1. So my y-intercept is 1. So the first line, I've got a y-intercept of 1, and I've got a slope of 2. What does the slope of 2 mean? Up 2 over 1. Up 2 over 1. So now all I'm going to do is go ahead and draw my line in then. Okay. Yeah, I don't know why we used bright green. We'll get rid of that. We'll put purple back on. Okay. So there you go. So now what I'm going to do is I'm going to do the same thing with the next equation. But what do you notice about the next equation? It's not fully in standard form. So I'm going to put this in standard form by just switching the x and the y around. There we go.
Is it still
So
supposed to be a negative 16?
Oh, yep, you're right, good call. There, -16. All right, so let's look at this next one. So the slope in this case is what? -5 over 2, good. And then the y-intercept will be 16 over 2, which is -8. So I'm going to go down -8. 1, 2, 3, 4, 5, 6, 7, 8. And the question is, how do you graph a -5 halves? In this case, what you're going to do is you're going to have to go up and to the left, since you can't go down and to the right. So I'm going to go 1, 2, 3, 4, 5, and I'm going to go over here to the left. Oh, look at that. That worked out really slick. Okay. Now, mind you, you still have to put the line through it. What's wrong? So here's your -8, right?
Yes.
Okay, a slope of -5 halves means you can go down 5 to the right 2, or I can go up 5 to the left 2.
Why on slope? Why did you get -5 over 2?
Because it's -a over b.
Oh.
Okay, well, let's change that a little bit. There you go. Okay, so where they intersect is where my solution is. So where do those two lines intersect? -2, -3. So that will be my answer. -2, -3.
Now you said we could either go down 5 into the right 2 or up 5 into the left.
Yes, yes.
Why can we do that? Yeah.
Because that's what a negative slope is. See, in this case, when you're going up 5, that's actually a +5. And then so the negative comes from with the fact that you go to the left 2, because that's actually a -2.
Would it do the same if it's gone down 5?
That's 2 years.
See, if I would have went down 5 here, which I would have ran out of room, and over 2, that's going to put me down here, right? And then I'm going to draw my line in, and it's going to go through an intersect. Okay, let's go ahead and look at another one.
That's you.
Okay, just to make sure we've got things down. So the first thing you need to do is find your slope of your first line. So what's the slope going to be here? -1 over -2, so my slope is 1/2. What's your y-intercept going to be? Yep, y-intercept in this case is going to be 0 over -2, which is 0. So, y-intercept is 0. Slope is 1/2. What does that mean? Up 1 over 2. Now, once again, for those of you, let's look at the previous slide. I could have went down 1 and to the left 2, and I would have still been okay. So let's go ahead and draw our line through there. So let's do the second line. What's the slope of the second line going to be? -1 over 1, which is -1. What's the y-intercept going to be? 6 over 1, which is 6. Okay, so 6. 1, 2, 3, 4, 5, 6. Slope of -1 means what? Down one to the right one. So now I'm going to go ahead and draw my line in, and notice it looks like it's already going to intersect. And so my task is just going to be to find out what point they intersect.
And what if they don't intersect?
They will.
They always will?
I won't say always, but most of the times they will, and we'll talk about that in a little bit. So what's my solution going to be here? 4, 2. So questions. So we've used a table, now we've used a graph. And there's a lot more other ways. But for today, we've used a table and a graph. Now on the next slide, you're going to notice we have a classification of systems of equations. First of all, we can classify things as consistent or inconsistent. Consistent means you've got at least one solution. So everything we've done so far has been consistent. Inconsistent means you have no solution. And so then the question is, what does it mean when it's got no solution? Okay? And so if you look down here at the very bottom, okay, at these graphs, when it was inconsistent, it had no solutions, what type of lines do we have? Parallel lines. So inconsistent means the lines will not intersect. That will happen on occasion. They won't intersect, they're parallel. And so as a result, we call those systems inconsistent. Okay? We also have independent or dependent. Independent means you have exactly one solution. Dependent means you have an infinite number of solutions. So example of something that is consistent and independent. That is what we've already done. They intersect at one specific point. Consistent and dependent means they're actually the same line. So that means they will have all the solutions on that line. So that's when they say an infinite number of solutions. So you're going to actually have to classify systems of equations now as consistent and independent, consistent and dependent, and inconsistent. So let's go ahead and flip over. You've got 2 problems left for today we're going to look at. Instructions: graph each system of equations and describe them as consistent and independent, consistent and dependent, or inconsistent. So the first thing we need to do, exactly the same steps we did earlier. Find the slope and the y-intercept. What's the slope of the first line? -4/3. What's the y-intercept? 24 over 3, which is 8. So let's go ahead and graph that. 5, 6, 7, 8. And -4/3. What's that -4/3 mean you do? Down 4 over 3. Okay, what's my slope of my second line? Yep, negative of -3, which is a positive 3 over 5. What's my y-intercept going to be? 30 over 5, which is 6. Okay. So here you go. And then a slope of 3/5 means you do what? Up 3 over 5. So let's go ahead and graph that line.
Oh, you went.
So we need to classify this. How many solutions does it have? 1. So we know it's got to be consistent. And is it going to be consistent and independent or consistent and dependent? Independent. So I'm going to let you abbreviate. This is how I let them answer Okay, I let them abbreviate. Consistent and independent is C and I. Consistent and dependent, we will use C and D. And then for inconsistent, we will just use I. Okay, so then that way you don't have to write out all those words. Independent basically means you have one solution. Dependent means it's the same line. So let's go ahead and look at our very last one, and then we'll call it good for today. Okay, so I need to start. What's my slope of my first line? 2/5. Nice job. What's the y-intercept? 2. So we're sure catching on to that trick. Saves us a lot of time. 2, 1, 2, 3, 4. So what's your slope on your next one? -4 over -10, which is what? 2 over 5, good. What's your y-intercept? -20 over -10, which is 2. What do you notice about those things? They're the exact same as the first one. So as a result, what do I know my solution is? Right, it's consistent and independent. It's actually the same line. Now, can you stop when you notice that the slope and the y-intercept are the same? Yes. And you can just go to consistent and dependent because you know it's going to be this first line that you graphed. All right, I think you've got about 6 problems is all for tonight. Okay, so it's not a lot. And if you actually work now, you might be able to get done with your homework so you don't have to worry about it tonight. Graph paper is in the top drawer on the right side. Okay, 28 through 38 evens.